Thank you, and thank you, Matt, for that introduction. I hope this doesn't suck. So hopefully I stay up to your guys' expectations. And the funny thing with the person who hacked my account, I actually found him like 2 months ago. I sent him a message and everything. I was like, hey, were you that guy? And he's like, oh my God. And it was like a blast of the past for him. So title of my talk, and it's funny because he's not in the industry. He doesn't do anything with malware. I think he was like a developer or something now. So the title of my talk is Reversing Threat Intelligence, Fun with Strings and Malware. The cool thing with this talk is when I gave my first security presentation, the title of it was Fun with Strings and Malware. Gave it at a local place here called Nova Hackers, so shout out to those folks there. So a little bit about me. My name is Ronnie Tokazowski. I'm a senior malware analyst with FlashPoint. Used to be with PhishMe, now FlashPoint. And as Matt pointed out, the stuff I did with BEC, you can find it over there with PhishMe. I like to hack things. I also like to tweet a lot. So my handle is iHeartMalware. I also like cooking as well. So I like doing kombucha. I like making real barbecue, AKA North Carolina-style pulled pork. The Texans in the room just cringed. Sorry. No, I'm not, but. I've also done a lot of work on the BEC side. If you guys see it and want to start collaborating on some of the stuff, hit me up afterward. I'll be at the booth, at the FlashPoint booth after that. Do a lot of work with crimeware as well. I've also done a lot of APT in my past life, as well as trolling the attackers, which is just something that's a whole lot of fun to do. So what I'm going to do in this presentation is I'm going to go over the deep and dark web. And no, it's not something from Mr. Robot or some other CSI thing where it's just a buzzword, but there's actually more context to it. It makes more sense than the buzzword. I'm going to go ahead and define malware for you guys, as well as strings. So I'll go ahead and talk about Yara and some stuff on VirusTotal, as well as how to programmatically create Yara rules. And the cool thing is the attackers are human, and that's kind of the aspect I want to make clear for you guys and everything. And now I'll go ahead and close out. So what is the deep and dark web? 30-second spiel. Pretty much if it's a .onion address or if it's a forum where you have to be vouched in order to get on that, that's the stuff we're looking at. So you have the attacks as they come in, but this is kind of looking at the malware as it's being developed and actively developed. It may not be completely public, but it's one of those things where a lot of the stuff that we're going over does tie back to that. And it also is applicable for other means too. So it just kind of gives you the picture of where that is. So what is malware? Long story short, it's something that's malicious that you can go ahead and send back and forth to your user, or if you're in the vendor space, it's something that I can sell you a solution for. So as we all know, if it's malicious, well, you can have this new IDS, DLP, cyber threat synergy thing. Also, there's clouds and next gens and threat bots. So if the malware is something that can be a vendor can sell you a solution for, that's malware. So what are strings? The best way to look at it are strings are these things that reverse engineers use in order to make it sound really fancy, but it's actually what we use to cheat. And it's also a way that attackers communicate. And also, for what it's worth, this thing here is a string. But the interesting thing with this string is this is a panda string. So what this panda string likes is this panda string likes Visky, with a V, as put earlier. But the cool thing is this string is actually a pretty smart string. So the interesting thing is with this string, string walks into a bar. So string walks into the bar, talks to the bartender, and says, hey, can I get a drink? Bartender looks at the string and is like, no, you can't have a drink. You're a piece of string. I'm not going to give you that. So the string looks back at the bartender and is like, okay. So walks away. So what he does is he goes and fills his hair a little bit to try and start hiding his identity, because that's what panda strings do. So he went, made his hair a little bit better. He's like, okay, I'm going to go get me a drink this time. So string walks into the bar the next day and everything, and he says, hey, can I go ahead and have a drink? So a bartender says, aren't you that same string from the other day? He's like, yeah. So walks back out. So he's like, the panda string, he's like, okay, I got my ID. I know exactly what I'm going to do. I'm going to do a little bit of twisting, trying to get it to go and everything. So he's like, all right, I'm getting my drink now. So string walks into the bar and everything. It goes up to the bartender and says, hey, can I have a drink? Bartender looks at the guy, he's like, aren't you that same string that was here the other day and asked me for a drink the previous 2 times? String looks at the bartender and says, nope, afraid not. I heard some groans, and I'm sorry for the corny dad jokes. But it's actually applicable, because if you think about it, that string is someone who's writing malware. They're constantly trying to bypass all our technologies. But as analysts, we're constantly looking at the string and at the things as they change. So that's how we can help tell that story and start catching the bad guys. So some of the tools as malware analysts that we use, we use Windows VMs. If I had a quarter for each time somebody asked, Ronnie, what's your favorite tool to use? My #1 favorite tool to use is Notepad++. And the reason I like that is because I can take a binary, throw it into there, right-click, open it in Notepad, and it has all this wonderful gibberish. But the cool thing is you can actually start looking at how the different files are set up and how the format is split up. So you can see, okay, am I dealing with a Windows executable? Am I dealing with an ELF binary? Is this packed? Is it not packed? Is it obfuscated some way? So when you start looking at that, you can kind of figure out the different aspects of that. So that's honestly, Notepad++ is probably one of my favorite tools. One of my second favorite ones is Yara, just because you can go ahead and create signatures for stuff that your attacker doesn't necessarily think of, but you can tie back the information that they have there. And then also looking at .NET for decompilers, because it's just great decompiling their source code and seeing exactly how they wrote it, which we'll be coming back to that. And then my other favorite tool is XOR search. You would be amazed at how many attackers to this day still use an XOR, just a straight single byte XOR. In the last 6 years, I constantly see it. Even with Mirai, I've seen that as well. So one of the cool pieces of malware I've gotten to analyze lately is I've gotten to look at a lot of the pro-ISIS tools and a lot of the malware that they've been writing. So if you think about it, when we think of ISIS, we think of this as some super sophisticated terrorist group. They're getting tons of funding, and they're very hard to stop, so it's a big problem. Complete opposite of that. So the attackers who are behind ISIS, a lot of them is very, very rudimentary. Last week they had a drone, and in one of their marketing videos, and I was looking at the drone, and I enjoy flying quadcopters. So I'm sitting there looking, I'm like, that's a 5.8 gigahertz antenna. That's a hobby grade remote. And I'm sitting there looking at that drone, and I'm like, that drone was maybe like $200. I'm like, I could build something better in my basement. So so for them, the tools and stuff that they're using is very rudimentary. So one of the cool tools that we came across in the stuff that we were looking at, the one person named Turgeman, we'll just call Turgeman, he was a French speaker. And what he did was he wrote a tool for encrypting communications back and forth. So when we were looking at the code, we identified that he was a French speaker, and we were able to tell that based off of the way he wrote his code, because he was using French words in there. The project name was Infos Encryptor, which didn't really make sense. But the interesting thing was the path that he installed it to was C program files, Turgeman, and then Infos Encryptor. So once we pivoted off of that, we were able to find other tools that he wrote too. So when you look at the tool for encrypting the traffic, it's very rudimentary. It's very drag and drop. What you do is you put your encrypted text in the top, and then you can decrypt it. And he also wrote he used Arabic in for a lot of the buttons. So I went ahead and I decoded the Arabic so you can go ahead and read exactly what the buttons do. But as I said, it's very point and click. So I push button, I get thing. I push button here, I get thing here. So it's pretty much just, it straight decodes it. And then the text box 4 is a 496-bit RSA encryption, and that was the lowest it could do. So you can even go up to like 100,000 if you want. It takes like several hours to decode or encrypt. So another tool that he wrote is he wrote a program called Deleter. And what it is you can preload the Deleter file with different binary paths and different paths for different files. So if you have somebody coming in raiding your house and you want to delete all your evidence, you can use Deleter to go ahead and delete those files if someone was looking at it. So the way that he implemented it was he just used like directory moved and directory delete. So it really wasn't forensically sound for deleting the files. As I was testing it, and as you start doing stuff with forensics, you'll realize that even though someone's trying to delete something, there's still data on the disk. And even if there's data that's not specific to that is on the disk, you also have other artifacts that are there too. So it's worth mentioning that even though he tried to do it securely, it really wasn't. And it was just the way he implemented it, you could tell that this was one of the first programs he'd ever written. And playing into the French aspect of it, you see where he was using less info. And that was also French for the info, I guess. And then there was also other French words that he was using in there, so we know that he was so we knew that he was comfortable programming in French, and then the other buttons were in Arabic, so we knew that French was his native language. And then it's like it would work, but it was buggy, and it really wasn't that great of code. So also tying back to dark web stuff, Mirai, which is IoT malware, and for those who haven't heard of Mirai, it was the DDoS malware that was used to hit Brian Krebs. It was a DDoS malware that took out Dyn, which knocked out a good bit of the East Coast here, as well as a bunch of other stuff. And the interesting thing is that the Mirai malware is compiled for different architectures. So it's compiled for a lot of IP cameras, a lot of DVRs. It's been used in a lot of many large-scale attacks. It's also accidentally broken things, such as one attacker used it to exploit the TR-069 protocol, which is it's a routing protocol that TalkTalk was using. So 100,000 users of TalkTalk out in the UK had gotten knocked offline when they were trying to infect with Mirai. So it's got a lot of things that have broken. If you haven't checked Krebs' most recent article, definitely check it out because it talks about some of the actors behind Mirai, or behind one of the bots of Mirai. And some of you guys may have seen the leak of Anna Senpai, who was the one who originally leaked the Mirai source code. So when you look at the Mirai malware, it originated from the DDoS community and originated from the booter community and the hack forum communities. And a lot of these kids who just want to knock each other offline when they're playing PlayStation or Xbox or whatever, just to get the edge. The more we started looking at it, the more red herrings that were in the malware. And it's just, you had little things that didn't really make sense and that were in there, but completely tied back to something else, to the point where the key that the attackers had used is they had used dead beef in hex as the encoding key for their malware. And it's like, okay, and when I was looking at it, I'm like, okay, it's going to be a 4-byte XOR key, go ahead and iterate through it, and it just really wasn't coming out as I would like it to. And like I said, as you see with the Raptor and the Rocket, you can definitely tell it's a Photoshop from the pixels, as well as all the red herrings that were in there. But one of the beautiful things with XOR is one of the inherent things of it is if you have a piece A and piece B, you can get piece C. So if I take piece A and piece C, I can get piece B. So you can get the other information. So here, when I was trying to figure out what the XOR key was that they were using, I had the encoded data that I had used. In their comments of the code, they said the here's what the decoded value is. So I just took the value A and value C, did a single byte, and I XORed those together, and it gave me my key of 22 hex. And the cool thing is they went ahead, and in most of the Mirai samples I've been looking at, it's been 22 hex. When the TR-069 stuff went public, the attackers had modified that to use exploit code, which was a different set than the original Mirai authors. And then we posted a blog post about that. So the interesting thing was once we mentioned the XOR of the 22 hex, the other Mirai authors went and changed the malware based off of that. So a lot of interesting stuff around Mirai and how they changed that. So if you've never seen an XOR, don't know what it is, it's a bitwise function. The way it works is it's just an easy way to make data look different. You can also zero out information. So if you're working with assembly and you see something like XOR EAX, a number XOR with itself is always 0. So you can use it to clear memory, clear registers and stuff. It's also very cheap on the CPU. So if you're writing shellcode or if you're writing an exploit, a lot of attackers like to use that just because it's a one straight simple instruction from the x86 instruction set that you can go ahead and use. And it's as I said, it's very cheap. And believe it or not, a lot of attackers use it. And the cool thing is in Mirai, they were actually using it to to send rickrolls, to send payloads. I've seen it in Word documents with executables embedded inside of them. So it's something that every attacker uses for all of these years. And I still don't know why they keep doing it, because it's easy to break and fun to break. So as I said before, there's like an inherent vulnerability in an XOR. I wouldn't know if it's vulnerability or feature. But as I said, if you XOR data with itself, it becomes 0. So if you XOR the data while it's encrypted, you also get that key back. And the great thing is also if you take a key and you XOR it 42 times, or if you take a value, XOR it 42 times, it's still going to be the same data, because you know that with the 42 times, it's still going to be the answer. So it's always going to be something even that you can get the same data. So multiple passes aren't always effective. I was explaining to one coworker, and he was saying that there was one group who did an XOR with several keys. And I drew out the math for him and everything. I showed him that even though they did it with the several keys, all you need is that one key. And it still doesn't matter if they use 16 different keys of a single byte XOR. You can still get the computation of those 16, figure out what that key is, and you can get your original value. So multiple passes are not effective against XOR, but attackers still use it, which is great. It makes our lives easy as reverse engineers, because it's magic. So that's one of the cool things that you can do is you can actually guess the data that's in there. And when you know the data that your end result is going to be, and you know what your key is going to be, you can start working the other way. So if I have my decoded data as well as my key, I can start guessing what this next value is going to be over here. And for Mirai, this was really cool, because a lot of times they just did a single byte XOR with the 22 hex. But what if the attackers go and change that? What if they know that that's something that I know, and they go and try and make that better? So if you take nothing away from this presentation, take these next few slides away, because this is something that you guys can use. This is actionable information that you can use to protect your enterprises. So listen. So the cool thing is that with Yara, you can do a lot of really cool things with it. You can also pre-calculate a lot of information based off of those known values. So if you know that an attacker is going to use Microsoft.com and you need to have a permutation of that, you can start using different values to figure that out, to use Python to write out your YAR rules for that. The great thing is if you know that you can look at magic bytes as well. So if you're trying to find a Windows RAR file that has an executable inside of it, you can write your YAR rule for the magic bytes of RAR at the beginning, looking for .exe with no case. There you go, RAR file with an executable. Stops every time, you can detect it. Looking for a zip, pk.exe, done. I mean, it's the best way to think of it is think of it like an IDS for binary data. You can do a lot of really cool information with it, and it's Boolean logic, really good way to write rules. So let's go ahead and take a look at the decoded data for Mirai. So you can see up here in the red, you have the words root and admin. So the interesting thing is that is in every sample that I've seen. And the reason that is in there is because they're using that to brute force the passwords of the routers in order to compromise the routers. So if they go ahead and get it in, it'll install Mirai onto there, and then they can go ahead and it will just continue being used for the DDoS. The ones that are in blue are not necessarily always there. So the first ones in blue, the Santa's Big Candy Cane, those were the attack domains, they're the C2 domains that this author was using. And then listening ton 0 was just, again, one of those artifacts that was constantly in there. As I mentioned, the YouTube link right under the first Santa's Big Candy Cane, that was actually a Rickroll link. So if you follow it, it's just a straight Rickroll. And then also one of the things that a lot of attackers have used in different DDoS malware is the LOL no GTFO. So now that's what we're going to use in order to go ahead and create our YARA signature, because this data here it's decoded, but it's decoded with a single byte XOR of 22 hex. So one of the cool things is we can use Python in order to take that string. We could then use a single byte XOR to take that data and try and figure out, okay, what's a single byte XOR of LOL no GTFO look like with a value of 1? What's that look like with the value of 2, and the value of 3, and the value of 4? And you could create a YAR rule for that. And the cool thing with creating that YAR rule is even though now you have a signature that looks for encoded data inside of the binary that you can use in order to detect what the key is. And you can even take that a step further. Let's say I have a Word document that has an exploit, and one of the ones that was popular was CVE 2012-0158, which tied back to the Trandui Lin attacks. So one of the cool things that they did was also they would XOR an executable and append it to the bottom. So now if you start looking for the magic bytes of this program, which is in the DOS header, you can now start detecting a single byte XOR inside of a malicious Word document. So you can now start using that to find ODAs and different attacks as they're coming against your enterprise. If they use something like an RTF, you can go ahead and expand that. Instead of just using the hex, you can now use that for the RTF files. So don't forget your ASCII love, just because that can be used for, Zeus was using that a lot, where they would append the executable on the bottom of it, but would render as ASCII. So now you're able to start detecting a lot of these different attack vectors. And yes, I know this can probably be written in an easier one-liner, but I wanted to space it out make it easier to see. So once you go and you generate, this is what your rule looks like. You have your hex value, and then you have your ASCII value, and it goes all the way down. And as I said before, if you could look for this program, that is absolute money in the network. You will help stop a lot of your stuff. You'll help detect a lot of your attacks that are coming in, and you can start seeing a lot of that. So that is like a money signature looking for just this program, single byte XOR, from 1 to 255. So in closing, malware authors always are trying to be one step ahead. But if you remember with the string, we were able to detect that the string was trying to buy a beer, and based off of the different attributes of that, we were able to pick up on that. So if we call them out, and if we say that they're trying to do something, they're going to go back and change. Likewise, when we were looking at the Mirai family of malware back with the TR069, those exploits were being used for other stuff as well. When we called them out, they completely changed that. So as researchers, a lot of the stuff that we post out there, attackers are looking at. And I've seen this in many cases, be it with Dire or with Drydex. I could sit here and tell you some fun adventures with the Dire stuff. So one of the things that we did with Dire is we tried to, when they were very active, we tried to push them as hard and as fast as we could. So the cool thing with doing that is they would change their malware, we would post a blog post. They would change their malware, we'd post a blog post. So there were several times where we would want to, and we figured this out early on. So we would go ahead, and when they would go and post something, we would try and burn a certain aspect, but not another aspect of it. And the interesting piece with doing that is you're now starting to understand the psychology and how your attacker interacts with you as a person. So the cool thing was that the attackers slipped up one time and started yelling at some researchers on Twitter. So good story, we actually have one of the actors. I got a picture of one of the actors. So that was fun times. So you always have to think one step ahead of your actors.